In control system, almost all the systems are represented one or other way. Basically, there are two types of representations. One is a block diagram representation, other one is signal flow graph representation. Both the representations are almost same. While representing these two, we take the same equations, but whenever we find the transfer function of the entire system, the method we follow differs for the block diagram as well as the signal flow graph. Now we'll see block diagram representation. What do you mean by block diagram? So block diagram of a system is a physical representation of functions performed by each component and the flow of the signal. Basically, block diagram depicts the internal relationship that exists among the various components of the system. So in block diagram, there are basic elements available. What are the basic elements of the block diagram? There are three elements available. The first one is block. What do you mean by block? Block gives the transfer function of the individual system. For example, inside the block, if you write G, so G is the gain or transfer function of the system, which takes the input, let us say X, and output is Y, and Y by X is a G. Whenever you want to represent the gain or the transfer function of individual system, we represent it as a block. The second one is summing point. What do you mean by summing point? In any system, one or more materials or energy or signal ought to be added in the system. So if you want to add any signal, we need to use the summing point. And the summing point, there are 2 input summing point, 3 input summing point, or and so on, 4, 5, 6, any number of inputs can be added using the summing point. So in this figure it is clear there are 3 summing points are there, a single summing point, but 3 inputs are there, x1, x2, x3, and output is y. What will be the y? It is x1 plus x2 and x3, because x3 we are taking the negative value, therefore x1 plus x2 minus x3 is the y. So this element is called summing point, which is very useful in block diagram representation. The third element is takeoff point. So in a system, let us say input x is coming, there is a block and output y, and this output y, I want to use it for some other purpose, maybe that energy, that material, that signal useful for some other purpose. So I want to take that signal. If you want to take the signal, so we have takeoff signal or takeoff point. Using the takeoff point, we can take it out and we can use it. So these are the 3 basic elements of your block diagram. Any block diagram consists of only these 3 elements. Let us look at what are the advantages of block diagram representation. The functional operation of the system can be observed from block diagram very easily, because all the blocks are available. You know what this block does, what this block does, and what will be the overall function of the system can be easily observed, can be analyzed using the block diagram. Similarly, it gives the performance of the system. One or other way we can easily find out what will be the performance of the system by looking at the block diagram representation. Similarly, block diagrams is used for analysis and design of the control system. This is what we want as a control engineer. We want to analyze the system, and as well as we want to design the system for any given design specifications. So block diagram is very useful in that case, and it is very easy to construct and also very easy to represent very complex systems. The systems can be any type of system. It can be electrical system, it can be mechanical, pneumatic, hydraulic, any system can be anything. So we can easily represent, and the construction is easy using block diagram representation. But still there are some drawbacks with the block diagram representation. The block representation is not unique, right? So we can represent them in a different ways. And also in block diagram, we don't give the input, means the energy sources we are not going to show it. So a source of energy in the system is not shown in the diagram. And in the procedure, so while transferring one block to another block, or while reducing these blocks, it takes a lot of time and it is tedious. Sometimes as per the functional wise it may be illogical. So we need to, no one is going to check it how it is happening and all. So this can be taken as a drawback. Similarly, it does not give any information about the physical construction of the system. So some of the drawbacks of the block diagram are like this. So now we'll see what are the block diagram rules available. So very first rule, if you look at, I have G1 and G2, and these two are connected in series or cascaded form. So we can call it as a cascaded blocks. I'm giving input X and this is the output Y. So I want to reduce this system into a single block. That is what the any rule says. Means whenever you have two blocks and each block has its own transfer function or the gain G1 and this is G2. So if you look at the signal flow, X is coming and X is multiplied with G1, therefore that becomes XG1, again multiply with G2, that becomes XG2. So what is a Y here? Y is nothing but X into G1, G2. Then when you replace this with a single block, it is very simple. G1, G2 in a single block and input is as it is X and output is Y. So Y gives the X into G1, G2. The main logic here in rules is before reduction for any given input, whatever the output you are getting, after reduction for the same input I should get the same output. Whatever the in between you do, but output should be same for any given input. So with this point keep in mind, so we can develop any number of rules and we can reduce them. Right, now second rule we can say when blocks are connected in parallel. There are many practical cases where systems can be connected, operated in parallel, connected in parallel. Now, so here I have G1, G2, these two blocks are connected in parallel. So when these two are connected in parallel, when we say these two are connected in parallel, the same signal is coming to G1 and same signal is coming to G2. So whatever the output you are coming, you are going to sum it. You are going to add. It can be add, it can be subtraction depending upon the your physical nature of the system. Now, what will be the output for any given input? So for this system, X is the input, Y is the output. So we can find out this is XG1 and this is XG2, and when you add this, Y is equal to XG1 plus XG2. You can take X common, so Y is equal to X into G1 plus G2. So what will be the resultant? Resultant we can write it as G1 plus G2, X is equal to Y is equal to X into G1 plus G2. In a single block we can write it as G1 plus G2. So whenever you have any parallel blocks, simply you just add or subtract depending upon the summing point polarities. Third one, feedback loop. This is very important. The ultimate aim of any block diagram is to convert into a loop. So once it is in the loop, then using this formula we can find out the overall transfer function. Look at how it the loop. Loop is a feedback path. As we have studied the basic control system, we have the negative feedback block. Therefore, I am taking the negative feedback system here. X is the input, summing point, and G1, G2 we have. G1 is forward gain, G2 is the feedback gain, and Y is the output. Let us assume some intermediate point here. This is X, I am taking input, and this is E, and this is B, and this is Y. And how can we write the relations here? Let us look at the Y. What is Y? Y is E into G1. Then what is E? E is very simple. You have X input and B feedback which is coming. Therefore, E is equal to X minus B. Then how can you write X, Y now? So Y is equal to XG1 minus BG1. B also we know in terms of Y, that is Y into Z2. Again, if you substitute in the equation, finally you will get Y into 1 plus G1 plus Z2 is equal to XG1, and the transfer function Y by X is G1 by 1 plus G1 plus Z2. So in actual control system, in place of Z2 we'll take H. So the generalized formula for any feedback loop is G by 1 plus GH. In this particular case, it is G1 by 1 plus G1 plus G2. In the denominator, if you have place, which means it is for the negative feedback system, sometimes you will get 1 minus g1 plus g2, that is for the positive feedback system. So for positive feedback system, you will get 1 minus g1 plus g2. For negative feedback system, you will get 1 plus g1 plus g2. This is for feedback loop, or we can call the single loop. Now coming to other rules, we know we have a summing point. Summing point is also important element in block diagram representation. How these summing points can be moved when they are adjacently connected. Now look at the first one. In that, I have one summing point and another summing point. So the first summing point, there are two inputs x1 and x2, and the output of this is connected to another summing point, that is x3. And look at the signs which is given. For x1 it is plus, x2 it is minus, for x3 it is x1 is plus, x2 is plus, x3 is minus. Therefore you will get x1 plus x2 minus x3 as y. So y is equal to x1 plus x2 minus x3 for given these inputs. How many inputs are there? 3 inputs are there, x1, x2, x3. I have one output. So what I want to do here is, I want to interchange these two summing points. When you interchange, again for the same inputs, we'll try to check what will be the output. If the output is same, then I can say two summing points, whenever they are connected adjacently, can be interchanged easily. Let us verify. Now here I am taking x1 and x3, that is the second summing point, plus and minus, and I am taking another summing point, that is which is in the previous one, the first summing point, and the input is x2, so I have output. It's very clear from this, your y is equal to x1 minus x3 plus x2. So whatever the previous, you are getting the same output. Therefore I can say two summing points, whenever they are adjacently connected, we can interchange them without any loss. Similarly, summing point, we can connect any number of inputs. For example, if you connect 3 inputs, we can split into 2 input, 2 summing points. Look at here, x1, x2, x3 are there. I want to split it. Sometimes while reducing the block diagram, there is a need to split the summing point. So whenever you want to split, you can easily split it like this. Very clear. So 3 inputs are there, x1 plus, I have x1 here, x2 here, x3 here. Depending upon the polarities of here, we'll give the polarities, and you can easily split them. We can also interchange them. Just previous rule says that we can interchange summing points, so here also we can interchange them.